Hello, welcome to this channel. In this video I am going to show you to code in Fortran for the calculation of Bohr's magneton. Okay, so let me tell you something about what is Bohr magneton. So for this, let's go to the browser. Okay, and on the search bar let's search for Bohr's magneton. Okay, so you can see here this is Bohr magneton. Okay, this is Wikipedia, and Wikipedia says in atomic physics the Bohr magneton symbol denoted by mu v is a physical constant and the natural unit for expressing the magnetic moment of an electron caused by either its orbital or spin angular momentum. The Bohr magneton is defined in SI units by mu v is equal to E times h squared by 2me. Here E is the elementary charge of electron, h squared is the reduced Planck constant, and me is the electron rest mass, and also c is the speed of light. Okay, we don't need c for SI unit, so I will show you to calculate the value of mu v in SI unit, and its SI unit its value is 9.27 into 10 to the power minus 24 joule per Tesla. Okay, I will make the calculator to calculate this value in Fortran. So let's start. So I have to get the value, this value, okay, in the range of this. So for this, let's open the terminal by clicking on Ctrl plus Alt plus T, and this is the terminal. Okay, so I need to create a file in file. So for this I use gedit. Okay, so let's create a Fortran file. For this type, I am going to create this file on home button where I am right now. So to check it, type pdw. Okay, I am in home directory. Okay, which is named as Manus. So in this directory I am going to create a file named let's say short form of Bohr Magneton vm.f9 extension for Fortran file. Okay, and it is Fortran 90. F90 means Fortran 90. Okay, so let's open the editor. This is the editor. Okay, so let's use this. So here let's type. Okay, so I want to add some detail here. This program helps you to calculate Bohr's magneton. Okay, so usually use this symbol to write the detail, the Fortran coding file. Now let's start typing the code. For this you need to name the program, and I name it as, let's name it as BM. Okay, short form of Bohr magneton, and implicit noun as it is something is okay, implicit noun and we need to define some variables, and I use double precision for this. Okay, and we need mass of electron, charge of electron, E, and Planck's constant, reduce Planck's constant, and P for pi. Okay, so P for pi. To calculate P, you can use value of pi as 3.14 either, or here I show you to write the code for the value of pi, and it is we use tan function to calculate the value of pi. Okay, and it is arctan 10. Okay, this gives the value of pi. Okay, now we need to give the value of m, e, and s to calculate the value of Bohr Magneton. Let's call it bm1. Okay, to write the value, let's type enter the value of electronic mass in kg. Okay, it's the value of m, and this means computer should read value of m. Okay, after this you need to calculate, you need to give the value of enter the electronic charge in coulomb. Okay, charge in coulomb, this is E, and read E. Okay, after this we need to provide a value of H, Planck's constant. Okay, so for this again write function, write command, and okay, enter the value of Planck's constant. Okay, which is in SI unit. Okay, SI unit means joule per second. This is H. So here I have also use here single bracket. Okay, single quoted line. Okay, so we need to use here double quoted bracket. Okay, and also it reads H. So the formula for Bohr's magnetron is we can see here the formula is for SI unit mu v is equal to E h cut by 2 me. Okay, so first of all we need to calculate value of h scot. Okay, h1 means h1 here. Okay, so h1 is h by 2 pi. So here we have given h and divided by 2 times p. Okay, p means pi here. Now the formula for calculating the Bohr's magnetron is E into h1 divided by so 2 me. Okay, it means 2m. So we need to provide bracket here 2 into m. Okay, so now write value of Bohr. Okay, here also we need to use double quoted bracket. Okay, magneton is double bracket comma, so it is bm1. Okay, we also need to provide the unit for Bohr magneton, and it is joule. Joules or Tesla. Okay, and end program. Okay, this completes the code. Now let's check it whether it is correct or not. Okay, so let's save it by clicking Ctrl+S and go to the terminal, and we are in home directory. Here you can check the file. Here is bm.f90. Okay, let's compile the program by typing G Fortran and the name of file. Okay, if I run it, okay, it shows some error here. We need to use here also the double quoted bracket. Let's correct the I used only single quoted bracket, which is not correct here. Okay, let's replace it by double quoted bracket and save it. So again go to the terminal and run the program again. It must be correct now. Okay, it is correct now. Okay, it says enter the value of electronic mass in kg, and here we need to use trick to provide the value. You know the value of the electronic mass is, I think it is provided here or not, I don't know. Okay, let's check it. We can search here mass of electron. Okay, so this is mass of electron in kg. Okay, and we need to provide here mass in kg as well. So let's provide this value. Okay, so here is a long value, so if I copy it, okay, up to this, if I copy it and paste here, okay, I think it doesn't work. Copy and paste. Okay, it is working. This is the value. After this into, we have to use some trick here. So the trick is that we don't use this value. Okay, we use directly this. Okay, for this let me show you how to type it. So 10, it means this into 10 to the power minus 31. Okay, this value is in kg. Let's click enter and then enter the electronic charge in coulomb. You must be familiar with the electronic charge. So if I search in Google as electronic charge, it says the charge is this. Okay, same, we need to apply same trick to type this value. So let's copy the initial value, copy it and paste it here. Okay, paste. This is the base value, multiply value, and after 10 to the power 16 minus 16. Okay, to type this directly, type 10 e to the power 16. Okay, this is the electronic charge in coulomb. Okay, now we need to provide the value of h, which is Planck's constant. Planck's constant. Okay, the value of Planck's constant is this. Okay, kg meter square kg per second, which is joule second, joule into second unit. So let's copy it, and it is 10 to the power minus 34. Okay, let's remember that also. Copy the multiplier values and type here. Okay, there was 4. Okay, 10 to the power minus, it is 34. Okay, and it gives the value like this. Okay, joule per Tesla. So we have provided mass of the electron, we have provided charge of electron, and we have provided the value of Planck's constant. And you know the formula for Bohr's magnetron is in SI unit. Mu v is equal to E h squared by 2me, and we typed the formula as this, where h1 is h squared, p is pi. Okay, and it gives the value like this, which is in the range of 10 to the power minus 21. Okay, joules per Tesla. And what was the value in Google? It says 9.10 to the power minus 24 joule per Tesla. I think it is not correct. No, why this is not correct? 27 is correct. Okay, 9.27 is correct. I think I made a mistake on providing the value. What is the mistake? This is 31. Okay, this is 16. Okay, I made a mistake here. It should be 19. Let's run the program again. Okay, the value of the electron mass is this. Okay, let's copy it and paste it here. Click on OK, enter, and this is electronic charge. We just need to correct this value. Okay, copy and paste it here, and here 16 should be 19. Okay, press enter, and the value of Planck's constant, copy it and paste it here. Okay, sorry, paste it here. Okay, now if you click on enter, it gives the value like this. Okay, 9.27 and so on in times 10 to the power minus 24 joules per second per Tesla. Okay, which is the similar value as this. See, up to 9.274. Here is 9.27400 to which 009. Okay, 009 up to this value, it is correct. Okay, and it is after 9 is 7. Okay, from this it is different. Okay, so we can calculate the value up to this precision. Okay, and this is the range, joules per Tesla. Okay, this is how we can make a calculator for calculating the value of Bohr's magnetron in Fortran. We can add something here in the code. So for this, let's define an integer integer which is n. Okay, let's type here 100. Okay, 11. Okay, 11 is okay, no problem. 111 is okay. You can give it 100. Okay, no problem. So here let's add some code. Okay, first of all, what I am going to show you is write press 1 to calculate again. Okay, or press any number, integer number, to quit. Okay, to quit. Okay, so read so what we do, we must read n. Okay, here I have defined n integer, this is integer. So here we use if command. So if the command is n is equal to 1, if n is equal to 1, then what I can write here is, so let's delete this bracket here. It says welcome back. Okay, and go to 100, and it goes, if you click press 1, then it goes to this again, and it says enter the value of electronic mass. Okay, if you press any other number other than 1, then the program will stop. Okay, and if so, let's save it and run the program again. What I made, okay, this is, here is single, and I enter here double quoted bracket. Let's correct it. Single quoted bracket is okay here. So let's run the program again. Okay, it works. So this is the initial program. Okay, enter the value of electronic mass, and electronic mass is this. Let's copy. Let's run again. Let's copy the value of electronic mass, which is this. Okay, copy it and paste it here. Enter, and let's copy the value of electronic charge. You can type it here as well, but I feel easier to copy and paste because it is so long number. Now you need to enter the value of Planck's constant, and Planck's constant is this one. Okay, let's copy and paste it here. Okay, this is like this. Okay, it gave Bohr's magneton as this. We have calculated already here. Okay, but the difference is after this giving this value, okay, it the program is closed, and it says gives this line, okay, up to this line. Okay, but now it says the program is not closed yet, but it says press 1 to calculate again. If you press 1, then it says welcome, and it says enter the value of electronic mass. If you press any other number, then it says close. So if I press 1 and press enter, it says welcome back, and it says enter the value of electronic mass. Let's provide any value, and it gives value like this. And if I after this, it says again like this, and if I press any other number other than 1, for example 0, program will close like this. Okay, so in this way you can make a calculator which calculates the value of Bohr's magnetrons like this. So thank you for watching. We will see you in next video. Thanks for the time. Please don't forget to subscribe the channel before leaving, so that you will get the notification of the future videos first. Thank you so much for your time.